Hello, my name's Lindsay Cornell. I work for the BBC. I'm also chair of the World DAB Technical Committee. I'm going to cover the topic of DAB today. I'm going to talk about the DAB system, analog versus digital topologies, emergency warning system, and some final words and conclusions. So let me carry on. DAB digital radio provides more choice for listeners and more opportunities for broadcasters. It provides consistently good sound quality without any interference. And it provides radios which are easy to use with presentation that keeps radio alive in the modern age. The DAB core is designed for mobile reception. It uses VHF band 3, that is from 174 to 240 megahertz, and it uses a wide bandwidth of 1.5 megahertz. DAB delivers up to 1.8 megabits per second in a single channel, although typically it's configured for 1.2 megabits per second, as this provides a good balance between capacity and transmitter power. DAB permits up to 64 services in a single channel, although typically around 20 radio services with additional multimedia content are provided by operators. Now, DAB is a digital radio system, so it provides radio services, and those have user-friendly benefits. So services are selected by name or by logo, not by frequency. There's consistent audio quality. There's extra information, for example, text telling you what music is playing or describing some item from the news. Service following means there's no need to retune your radio when you're moving from place to place, for example, in a car. And multimedia applications are available to enhance the audio. So these might be slideshow images with album art. They might be extended service and program information or traffic and travel information. DAB Plus audio uses HEAAC version 2. This provides a low and consistent audio delay for all services and a clean point of failure characteristic at the edge of coverage. DAB is fully reconfigurable. That means the services can use any bit rate between 24 and 192 kilobits per second. That's at the broadcaster's choice. So some examples: in the UK, some pop stations use 32 kilobits per second for niche genres, small audiences. And as another example, Swiss classical music stations are using 88 kilobits per second for live concerts. Now, services can vary the capacity they use to allow pop-up service to be introduced for special events. And some examples are, for example, around major sporting events where additional channels are introduced, taking some capacity from other services. So they just run for a few hours during those special events, and then normal programming comes back again. Radio is consumed everywhere and especially on the move, for example in your car. Multipath propagation, that is the reflection of the signal off trees, buildings and hillsides, is a fact of life. What that means is that the signal arriving at the receiving antenna is composed of a number of contributions which have different delays and different magnitudes. Multipath affects all radio signals, whether they're analog or digital, whether they're terrestrial or satellite delivered. But with a wide RF bandwidth and appropriate digital system design characteristics, these problems can be mitigated. DAB uses a wideband signal to guard against fading, and it uses COFDM, coded orthogonal frequency division multiplexing. In fact, COFDM is used by all modern digital communications technologies. COFDM includes time and frequency interleaving, forward error correction, and multiple carriers. So the frequency interleaving distributes the errors due to carrier cancellation throughout the data stream, and the time interleaving distributes errors due to fast fading across a relatively long period compared to the symbol time. Forward error correction then allows the receiver to retrieve lost data by exploiting the redundancy in the transmitted signal. There are multiple carriers in a COFDM signal, and that increases the data rate available. So the benefits of COFDM are that it provides robust reception. It tolerates Doppler shift and signal fluctuations, and it tolerates multipath propagation. It also allows single frequency networks to be built, that is, where all the transmitters are operating on the same frequency. So when you want to extend coverage beyond one transmitter, you don't need to plan additional frequencies to extend that coverage. The receivers benefit from signals coming from several transmitters, which is something called network gain. What that allows is for a less dense network than you would require if the transmitters were on different frequencies, because little bits of each transmitter's signal can add together to provide the necessary signal strength. This provides high spectrum efficiency. So now I will turn to analog and digital topologies, the differences and the similarities between them. So in analog radio, AM and FM, only the audio signal is transmitted from the studio to the user. So in the studio, the presenter's voice and the music, for example, are mixed together, transmitted, and the user selects the service he wants by tuning to the correct frequency. With DAB, the studio process is the same for the audio, but there's additionally metadata supplied to give that user-friendly experience. The user, on a domestic radio with typically a small text screen, will select the station by the station name, in this case BBC Radio 3. In a car with a colour screen, the selection will be by the logo, which you see below. This provides a very simple and effective way for users to select the content that they want, especially when they're on the move and they don't want to be distracted by looking at their radio. Now, what about multiplexing? So DAB is a multiplexed system. Those radio stations all come together into a single channel. In analog, AM or FM, each radio station needs its own frequency. So if in a particular area, a particular city, for example, you have between 15 and 25 radio stations, you're going to need 15 to 25 different frequencies to allow those radio stations to be put on air. But with DAB, there's just one frequency because all of those radio stations are multiplexed together and carried on the same RF signal. So let's have a look at that a little bit more in terms of system design. So on the left, we have the studios, independent studios from different broadcasters, different colour, represented by different colours. And typically in analog, each of those radio stations then has its own transmitter. And those transmitters might feed their own antennas, but more commonly, the signals will be combined together and put out onto a single antenna or a single tower, because particularly in city areas, space is at a premium, it's hard to find locations to build all those towers. For digital radio stations, the studio infrastructure is more or less the same, although the audio will be coded from analog to digital, and those digital signals are then multiplexed together by a device called a multiplexer, and that multiplex signal is fed onto the transmitter, which then provides the signal up to the antenna. So in some ways, there are quite some similarities between analog and digital distribution of signals. It's just a case of whether the combining of the signals is done at the RF domain by a combiner or at the digital domain by a multiplexer. Now let me talk about coverage. If we want to extend the coverage area of an analog radio station, there's a point at which we cannot continue to increase the power of the transmitter. What we need to do is to provide another transmitter and for analog that means on another frequency. So the more transmitters you need, the more frequencies you need up to a certain point. Now with DAB you can use single frequency networks, and therefore more coverage only requires you to provide more transmitters. You don't need to find additional frequencies. And this means that you can fill in gaps and you can extend your coverage as the city expands, for example. You might need to cover a greater area than you did before. With DAB, you don't need to go back and find a new frequency in order to provide that additional coverage. So a little bit more about single frequency networks. There are great benefits from them in terms of network gain, coverage extension, and spectrum efficient hole filling. But one thing that is important to remember is that you can't localize the content in a single frequency network. The content, in other words, the content of each radio station within the ensemble has to be the same everywhere. Now, in terms of DAB planning, there's an ITU recommendation BS 1660. It provides all the planning parameters for DAB. There's also an EBU Tech 3391 document. It's a comprehensive guide to planning DAB. It's available for free download, and it provides lots of examples of how planning has been done in different countries, which is really a much more of a step-by-step way of planning DAB than simply from the parameters provided by the ITU. And in 2024, World DAB held a seminar all about planning a net of DAB networks, and the details and the presentations are available for free download from the World DAB website. And here's the link. I now turn to talk about the DAB emergency warning systems. So a brand new emergency warning system for DAB was created and published in 2024. There are two new standards which document the system description, the signaling and the receiver behaviors, and a specification that supports a receiver testing compliance scheme. Now, the key features of this emergency warning system are as follows. We have alert messages, that is spoken messages with the essential information of where, when, what to do. After all, radio is an audio medium. We need to convey the information we need using speech. We have signaling between ensembles to allow receivers to work out when an alert is active. And we have location targeting so that just the right people are alerted and anybody else who's in a different area is not affected by this particular situation doesn't get disturbed and can continue to listen to their normal programming. The system has sleep and wake up, so the receivers have a low power sleep mode, but they monitor a DAB ensemble for alert signaling even when they're sleeping, and every minute the receiver will evaluate the alert signaling, and if it's relevant to that particular receiver, the receiver will wake up, play out the audio, and it will retune to a different signal if that's needed. Finally, we have receiver testing. We have a formal testing specification to ensure that receivers react correctly to the alert signaling. And this technical standard is the basis for compliance schemes to allow consumers to identify products that have passed the testing. So there are three key innovations which make this DAB emergency warning system different from every other system that's available. And the most important is probably the location coding system. So the areas that are affected by an incident and the transmission coverage area of a radio signal are very rarely going to align. So we need a system to allow us to identify which receivers in which locations are affected and to leave other receivers unaffected. The DAB location coding system is globally applicable and it has a resolution down to about 1 square kilometre. It's a lightweight coding system. It's got very high coding efficiency. There's new signalling which was specifically tailored to alerting. So we identify which transmitters are involved in the emergency warning system. And we also identify incidents, which stage of an alert, is it the beginning, is it an update, is it a repeat of information that's already been provided? How important is this particular incident? Where is it located? And we have synchronization of receivers, and this allows all the receivers in the sleep mode to wake up at the same time, to check the signals at the same time, and this minimizes audio loss at the start of an alert. It also maximizes the battery life for receivers that are used after the mains power has failed. Now, it's planned to roll out the system in Germany during 2025. There will be a public launch in the second half of the year. And the reason that Germany is the first place to launch the DAB EWS is a result of planning following the flooding in 2021, where people lost their lives, where there was extensive damage to roads and bridges, there was water contamination, there were crop losses. And the communications infrastructure provided by the mobile phone networks was out of action for several days. The broadcasters and the governments in Germany decided that they needed a system that was more reliable during these extreme weather events. And we've seen plenty more extreme weather events since 2021. Now, to make sure that DAB receivers work properly for consumers, there is testing and certification. For several years, there's been an ETSI standard, which is for the basic receiver testing. It's used for the Digital Radio UK tick mark certification scheme, and this specification provides functional and performance requirements for DAB receivers and the test methods and success criteria for both the core technology, that is the chips and the modules, and for the final DAB products, the receivers that go into the shops. Now, for the EWS, this additional specification provides a similar facility for receivers designed to cope with the emergency warning system. So there's additional testing set out and the success criteria once again to achieve an EWS certification mark. And currently in planning is an EWS mark which will be used in Germany for the launch in 2025. So finally, let me turn to the current status of DAB around the world. So in Europe, DAB Plus is the core digital platform for radio. There are hundreds of DAB ensembles on air and thousands of DAB Plus radio stations operating every single day. In Africa, the Middle East and Asia, the opportunity for DAB Plus is being assessed. Australia has been on air and is established as it is in Europe. And just concentrating a little bit on Africa and the Middle East, this is where we are seeing a great deal of activity triggered by the shutdown of analog television across Africa and the Middle East, which uses the band 3 spectrum, band 3 VHF spectrum that DAB is targeted to use. So the opportunity to digitize radio, having completed the digitization of television, is now being taken up. Now, in terms of domestic automotive DAB receivers, we see cumulative sales of more than 120 million. And those receivers come in principally two form factors. So we have domestic receivers with a small text display looking pretty much like an analog radio, but having the advantages of easy to use, good quality audio. And in cars, we see large colour screens, and here the ability to represent your radio station using the colour logo rather than just a frequency really provides the opportunity to compete against the streaming services provided by the likes of Spotify and so on. So to conclude, DAB digital radio provides a wealth of benefits, provides more choice for listeners, more opportunities for broadcasters, consistently good sound quality without interference, and radios which are easy to use and with presentation that keeps radio alive in the modern era. So thank you very much for your attention. I hope you've enjoyed this presentation about DAB. And if you require more information, you can refer to the World DAB website. The URL is shown below.